Hey friends. So today we begin kind of the second half of the quadratics unit. In the first half, we focused mostly on quadratic functions, which was understanding what they looked like and then understanding the different forms we could write in, and then specifically what each parameter did with those specific forms. Okay. Then we looked at some applications of quadratics, and now we're going to turn our attention kind of to the second half. And in the second half, we're looking at solving quadratic equations. Okay, so we're going to do that by a couple of different methods. Today is going to be graphing. Tomorrow will be factoring. And then we'll talk about something called the quadratic formula. Okay, so when solving quadratic equations graphically, we graph each side of the equation separately and then look for where the two graphs intersect. So first of all, I'm just going to hide myself so that you can see that and make sure everybody can see the words of that top paragraph there for a sec. Okay. Now, what we're talking about when we're solving, so just let's back the train up for a sec. When I'm asked to solve this, I'm trying to figure out a solution, a value that I can put in for X here and for here that would make the statement true. So some sort of value I could put in for X where I'm going to get out that number there. Well, that number there is 0. That's like the Y value. So think about this for a sec. When I'm solving an equation and it equals 0, what I'm really doing is trying to find the x-intercepts of that equation. Okay. And we've already actually talked about that. We've actually talked about finding the x-intercepts by graphing, and we've found x-intercepts by graphing calculator. So what I'm hoping is that these first two lessons, graphing today and factoring tomorrow, are actually going to just solidify some of the things we talked about in the first half. Okay. Now, back to the graphing portion of it, though, we are going to graph x squared minus 3x minus 4 on one equation. And then as another equation, we're going to graph y equals 0. Okay. Now, the first thing I want to do is use this opportunity to remind you that you can do both of these equations, the x squared minus 3x minus 4 and the y equals 0. You can actually graph both of those by hand, just with everything you know so far. So I'm going to quickly walk you through a review of how to graph by hand. Then after that, we're going to also review graphing it by graphing calculator, just to make sure you're comfortable with both. Okay. So first thing I need to do here is I've got the grid there, and I'm going to find the y-intercept. I already know the y-intercept is 0, -4, because that's the constant term right here. Okay, so I'm just trying to graph this equation first. The y equals 0 is going to be the easy part, right? That's just going to be my horizontal line on the x-axis. Okay, then to get the x-intercepts, I would try and factor this. So I'm asking myself, is there two numbers that would multiply together to give me -4 and add together to give me -3? I know that those are -4 and 1. And then when I go to solve that, that's the zero product principle. So I've got x equals 4 or x equals -1. Okay, so I've graphed my y-intercept right here. I'm now going to graph the x-intercepts at -1 and 4. I would then take the average of those two x-intercepts, and that would get me the x value at my vertex, also known as the axis of symmetry. Okay, I'm hoping all of these words sound really, really familiar to you. So I'm going to go -1 plus 4, and then I'm going to divide by 2, and that's going to give me 1.5. Then to get the y value at that vertex, I just plug in the 1.5 back into this equation here, right? And so I go f of 1.5, plugging in 1.5 everywhere I see x, and I get out -6.25. So then I know that I have a vertex at 1.5, -6.25, graph that guy there, and now I can get a cute little graph there, no problem. Okay. Now, that is me reviewing some of the steps we took to algebraically figure out this graph. Okay. If you were paying attention in those steps, I also just solved the equation because the solution to the equation is actually sitting right here, isn't it? Because this equals 0, and that's what it equals 0 up there. So that's actually solving by factoring, which we'll do tomorrow. But just to finish this thought, okay, let's add in that y equals 0 line. And the whole point of the graphing aspect of it was to determine the solutions where the two different lines intersect. Okay, so take a look at this. Where do these lines intersect? They intersect right here at x equals -1, and they intersect, oh, I did a bad job of that -1, right here at x equals 4. What does that tell us? What do we mean when we say a solution? X equals -1 and x equals 4 are the only two values that I could plug back into the original equation and it be a true statement. I actually would get out 0. Okay, so if I plug in -1 for x right there and for x right there, I'm going to get out 0. Okay, if I plugged in I plugged in 4 for x right there and for x right there, I'm going to get out 0. If I plug in any other number but -1 or 4, I will not get out 0. X equals -1 and x equals 4 are the solutions to this equation because they are the two values that make the statement true. That's what we mean when we say a solution. And they are the only two values that would make the statement true. Okay? So when we are solving by graphing, again, we're looking at taking what's on the left and graphing that as a separate equation, and then taking what's on the right, graphing that as a separate equation, and looking for those points of intersection. Now, in this first example, I have done it all with you algebraically, just to again reiterate that you have the ability to do this without graphing technology, okay? But you also have a graphing calculator. So now we're going to switch over to your graphing calculator and try the same question there. So if you can just give me 1 sec, because I can't click and talk at the same time. And I'm just looking for, there it is. Okay. So on your graphing calculator, we're just going to review the same process of how to get this. On a Casio, you're going to press menu, and then you're going to go to the graph. Okay, so if you have a newer model, that's probably option 5. If you have an older model, that's probably option 3. Okay. And then if you have a TI, you're going to press the y equals button. That would be just around here on your TI graph. Okay. So in the first y1, I'm going to graph x squared minus 3x and -4. Okay, and then in y2, I'm going to stick the right side of the equation, which was 0. So I'm going to stick 0 in for y2, and then I'm going to go ahead and draw that. Just take note, I'm always pressing the execute button after the typing in the equation. That's what registers the equation. If you're ever typing and you're like, oh, shoot, I didn't mean to do that, you can just press exit and it will revert it back to whatever was originally there. Nothing gets registered until you hit execute. Okay. All right, so then we're going to press draw, and then we see the two graphs that I showed you by hand just 2 seconds ago. We see the parabola there, and we see the line that's intersecting. Okay, that's the y equals 0, and this is the x squared minus 3x minus 4 graph. Okay, now on a Casio, to get those points of intersection, we go gsolve intersect. Okay, which is F5, F5. It's going to take us to the one on the left right away. So we see that x equals -1. Okay, and then if we press our right button, it will jump over to the one on the right of that, which was 4. So I've got -1 and I've got 4. Okay. Okay, so now if you are a TI, you're going to do very similar process. Okay, you've already gone and put your y1 and y2 in with me. Okay, then when you press graph, you're going to get the same picture. But for you, when you go to find that intersection, it's second trace, and then option 5 will say intersect. Okay, when you press option 5, a cursor will appear and it's going to ask you some questions. It'll say first curve, second curve, and guess. Before you just go mindlessly pressing enter, 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 just make sure you move your cursor, okay, just close to the one that you want to get. Doesn't have to be right on it. You just have to be close. Okay, and then hit enter, enter, enter. And then you do the process again. So you go second trace 5, but this time move your cursor over so that it's close to the other one that you want. Okay, and then you can hit your enter, enter, enter. Okay, and then it will again also give you that -1. Whoops, sorry. It will give you that same answer of the -1 and the 4 that we talked about for the Casio kids. Okay. All right, so I'm going to switch back to the PowerPoint. Okay, and so I've got on the grid, I've shown you a picture. Now my picture looks slightly different than the one I just did live with you because my window settings are different, right? This one I took a closer in snapshot. So my X min is only going from -3 up to 5, and my X max is going from like -8 up to 5-ish there. It's actually probably -7 up to 5. But I can still see my points of intersection there at -1 and at 4. Okay, so now just as a reminder, if you're Casio, you're going to go F5, F5. And if you're TI, you'll go second, trace 5, enter, enter, enter. And TI kids, you'll just have to do that twice, one for each of the intercepts. Okay. All right, and then we had X equals -1 and 4. Okay. So those are the solutions to the graph, just like we did by hand. Same solutions when we do them by calculator. Okay. All right, now let's try x squared minus 3x equals 4. Okay, now I've already color coded this. So my blue graph is going to be the x squared minus 3x, and now my red graph will be 4. So you go in your calculator, change your y2 to just say 4, and in your y1, take the 4 away. So you'll just have x squared minus 3x. Okay, this is the picture you should be getting. And again, just keep pausing me so that you can try these yourself as well. Okay, and now we're looking again for the point of intersection, but what I want you to notice is the point of intersection hasn't changed. Look, it's still at x equals -1 and x equals 4. Okay, x equals -1 and x equals 4. All right, so what do you notice? Let me just hide my head here for a sec. What do you notice about the x-intercepts of the first graph and the points of intersection of the second graph? What you want to notice there is they are the same, okay? They are totally the same. Okay, now, what do you notice about the two equations? Okay, well, let's take a look. Didn't I actually just take this -4 and add it to both sides so it appeared over here? Okay, so really, aren't these two equations the same equation, just algebraic manipulations of each other? Okay, and that's why we actually get the same answer for them. They are actually the same. They are just algebraic manipulations of each other. Okay. All right, so let's summarize a couple things there. I'm just going to remove that ink, and I'm going to remove my head for a quick sec. Remember that another word for x-intercepts is roots or zeros. Okay, roots or zeros. When solving, when asked to determine, my head was in the way of the word, sorry. My head is in the recording, my head is always in the top right-hand corner, but I actually have to move my head around during the recording. When asked to determine the solutions to a quadratic equation, we are searching for the x values, which can be found at the x-intercepts when one side of the equation is equal to 0, or at the x values of the point of intersection when one side of the equation is equal to a number other than 0, okay? All right, good stuff. So determine the roots of x squared plus 5x equals 24 in two different ways. I'm just gonna hide myself for a quick second there so you can read the question. All right, and so way number 1, I could graph just as I see it, the left side being y1, the right side being y2. So in y1, I'm going to put x squared plus 5x equals 20, or x squared plus 5x. And in y2, I'm going to stick 24. Okay. Way number 2, I'm going to bring that 24 over to the other side. So I'm going to take this 24, head over here, okay, and call that x squared plus 5x minus 24, and graph that and look for the x-intercepts. Okay, so there's the two ways I've just described. Okay, you should be pausing me and you should be trying each way and compare pictures. Okay, I'm going to do the x squared plus 5x equals 24 first. Here's the picture I got. Take note of my window settings. I'm going from -9 up to 6 in the x, and I'm going from about -10 up to 30 in the y. Okay, and it looks like I'm getting an intersection of -8 and at 3, -8 and 3. Okay, On the other side of this, if I took this guy, this is the picture I'd be looking at. But take a look. Look at those x-intercepts. That's where that red line is now. I'm still getting solutions of -8 and 3. Okay. And again, what do those solutions mean? They are the only values for x that would make either of these equations a true statement. Every other value for x would not work. I would not get the 24 that I'm looking for in the first one or the 0 that I'm looking for in the second one. Okay. All right. What is the maximum number of solutions of a quadratic equation can have? How about the minimum number? And are there any other cases you can think of? Draw graphs to illustrate your reasoning. So I would love it if you paused and drew these graphs out yourself first. So welcome back. Okay, and so I want you to know that there's 3 cases. The maximum I can actually have is 2 solutions, but then I could also have 1 solution, or I could have no solutions. Okay, and hopefully you've been able to draw a graph of each one of those, but I've shown you one here. Okay, so here I've got 2 solutions. Here I've got 1 solution because my vertex is right on the x-axis. And then here I have no solutions because I don't cross the x-axis. Okay, so the maximum is 2, the minimum is none, and then we could also have 1 as another scenario. Okay, you got this. All right, let's end with a little word problem. A high diver stands on a platform 10 meters high. When she dives, she reaches a maximum height of 0.6 meters above the platform after 0.35 seconds. How long does it take for her to reach the water? Okay, so we want to draw a picture of what we're talking about. So I know that when the clock starts, I'm 10 meters high because that's where the high diver is standing. She's standing on a platform 10 meters high. So I know that I could go, okay, well, here's my X and Y axis. I could start at 10 meters and she's going to go up and then she's going to plummet down. So it should look something like that. Okay. I know that this point is 10. I know this is my maximum, and I know that my maximum will be 0.6 above the platform. So that should be 10.6 up there. That would be my Y value, right? And then my X value, well, it took me 0.35 seconds to do that. So I'll have 0.35 there. Okay. Now, my writing is pretty messy, so let me clear that and I'll put a computer generated version of the same thing there for you. So here's my picture, and those are the points that I know. This is enough to build my equation. You built equations in the first half of this time together. Sorry, I don't think I hid my head yet for those who may not have the question with them, so I'll hide my head right now. Okay, and now we're gonna build the equations. So this is my vertex, so the 0.35 will be my H, and the 10.6 will be my K. And then I'm going to use this as my other friendly point in order to solve for A. So I'm going to use my 0 as X and my 10 as the Y. So I start with my equation, Y equals A, X minus H, all squared plus K. That's the vertex form of a quadratic. Okay, I'm going to plug 10 in for Y. I don't know A. I'm going to solve for that guy. I'm going to plug the 0 in for X, the 0.35 in for Y, and the 10.6 in for K. Okay, so I've done that. Now I'm just going to grab my calculator. I'm going to go 0 minus 0.35, which is going to be negative 0.35, and then I'm going to square that. Okay, now before I freak you out on the next line, I squared it and I took my decimal and I just changed it to a fraction. So if you are a Casio, you'll just press that F to D button or S to D, depending on the model of your Casio. If you are a TI, you're just going to press Math, Enter, Enter, and then all of you will be able to get that 49 over 400. Okay, so now I'm looking at 10 equals 49 over 400A plus 10.6. Now I'm trying to get A by itself, right? So I'm going to have to subtract 10.6 from both sides. That's going to give me negative 0.6 on the left with 49 over 400A on the right. Now, I have to get rid of a division of 400, right? So I'll multiply both sides by 400, and then I'll have to get rid of a multiplication of 49. So I'll divide both sides by 49. Okay, so in your calculator, that's going to go negative 0.6, multiply by 400, divide by 49. And then you can change that to a fraction again by pressing the S to D button on your Casio or F to D, depending on your model. And then on a TI, you'll go Math, Enter, Enter, and you'll get negative 240 over 49 for A. Okay, so my equation is y equals negative 240 over 49, bracket x minus 0.35 squared plus 10.6. Now, we're looking for how long it takes for her to reach the water. So we're looking at that point right there. We want the x value, okay? So we could put y2 equals 0 into our calculator and solve the intersection point, just like we were doing in the last example. Some of you may see this as an x-intercept, and Casio kids, you'll know that you can also get your x-intercepts just by going g-solve roots, so you may want to do that. Just a reminder though, it'll take you to the left first, which is the one over here. So you're just going to want to then press your right button and take you right here, okay? But all of you, whether Casio or TI, have the capability of going y2 equals 0 and then solving for that intersection point, okay? I'm not going to do that with you because you've already done it a couple of times in this note. But do pause me and do it yourself. Okay, so you should have gotten 1.82 when rounded to 2 decimal places, okay? So that means it takes 1.82 seconds to reach the water. So we're just going to have some sort of a concluding statement there that answers the question that we were asked in the first place. Okay, so it takes her 1.82 seconds to reach the water. All right, guys, that's it for this note. As I've already alluded to, tomorrow's note will be dealing with factoring. I told you in several lessons how important factoring is, so you might want to brush up on factoring before you take a look at that note. For those of you who are struggling with factoring, I do have, if you just want to go to my YouTube channel, and just search Math 10C Peter Hill factoring, and you'll get some more in-depth lessons around factoring from my 10C notes. But you might want to brush up on that before you take a look at the factoring, solving by factoring note that we'll do as the next lesson, okay? So if you're ready for that, you can head right to that lesson. But if not, take some time to brush yourself up on factoring. Just searching those 10C notes, okay? At the moment though, I posted your homework for kids who are with me in class, and for all of you, make sure you're connecting with me and asking me lots and lots of questions. That's what I love. All right, have fun guys, we'll talk to you soon.